All right. First of all, it's mandatory, but life gets in the way. I understand with families and with COVID still out there. I mean, you've got states that are spiking, whatever. Long story short, yeah, I do take attendance. And at the end of the course, I'm looking for ways to bolster your grade. And I look, did you attend? And even though you had an excuse, chances are you're not going to get any kind of bonus points or any kind of boost if you're not attending my meetings. In fact, I will actually reach out to you and say, well, where the heck are you? You realize when you signed up for this course that 7 to 9 on Wednesdays. But I'm not going to be a hardliner because I don't know people's lives, what's going on. Like you don't know what's going on in my world. I surely don't know what's going on in your world. So you provide me with a valid excuse, I'll mark it in my attendance and we'll see how things play out. But in addition to, being mandatory, not logging into this stuff and looking at, going over the things I'm going to go over tonight, you're just hurting yourself. I mean, it's just like not attending class. When we're on campus, you don't show up for class. Here's how I equate this to, not attending class after you sign up is like going to Best Buy, buying something and then paying for it. And the cashier hands you the bag, you go, that's okay. I don't want it. You walk out. It's the same thing, not taking advantage. There's something else I'm going to say, and if you, as you get to know me on Wednesdays and even on Fridays on the non-mandatory Zoom office hours, I'm very direct. All right. I let you know what's on my mind. And if there's something going that is incorrect, I want to call you out on it. Here's what I'm seeing. Looking at the time in on Canvas, I've got some people who have spent 5, 6 hours already logging into Canvas. I can see the activity. I can see where you're clicking on, the pages you're clicking on, the number of hours or minutes. I've got some people who spent a total of 3 minutes, and I got other people who spent a total of 8 hours. And I'm saying to myself, 3 minutes. I published this course about a week and a half just to give you a head start. Primarily is to get that calculated and to get an idea of what you're going to be facing. And then I've got people logging in for 3 minutes. What is going through your minds is beyond me. 3 minutes, and I published it a week ago. You just want to scratch your head, and then they want to say, "Oh, the course was so tough." Yeah, you kind of knew this before you signed up. All right. If you've never taken a summer course or taken an intercession course, we're not doing less work because it's 5 weeks. No, we're taking the 15 weeks, a regular 15-week course, and we're compressing it into 5 weeks. So it's a heck of a lot of work. You should have realized this before you signed up. It just, all the years I've been doing this, over 30 years, and a lot of it, of course, hasn't been online, but since last March, some people do their due diligence and log on, do what they have to do, and other people just, and they wonder why they end up with a D. It's beyond me. Anyways, enough of that. Here's what I'm going to do. I'm recording now, and whoever we got here is here. I'm not going to worry about the folks that are naughty. There are always going to be people that, for one reason or another, can't make it. So here's what I want to do. I want to start off by sharing my screen. And before I even talk about that, Wednesdays are mandatory, 7 to 9. Now, tonight I may be on an hour and a half. It all depends how it goes. I don't want to do things that I assigned for tonight's homework. I want to go over the previous, which would have been Monday's homework. I don't want to get ahead of myself. So we'll see how it goes. How many hours do I go the entire 2 hours or not? But Fridays, if you're available, here again, this is not mandatory. If you're available, you use that same login. I'm going to be on from 11 to noon. Excuse me, 11 in the morning to noon for office hours. And with office hours, it's just a mini of what I'm doing right now. It's only an hour. And I'll answer any questions. Usually they have to do with homework assignments. But do me a favor, if you do log on, or even on these Wednesday night meetings, be prepared. All right. I have people ask, well, I got a question, and they're trying to find a question. Then I got to wait by the time they figure out where the heck that question is. There's a section 2122. We haven't got that time for you to be looking around for this nonsense. Be prepared. You got questions, have the question in front of you, have the sheet in front of you, print it out. Let's make, time is precious. Then maybe next week, Brianna brings us some steak and mashed potatoes. I doubt that's going to happen. And maybe we can go somewhere to the Virgin Islands with, who's in the Virgin Islands again? Somebody's in a virgin. Amber, there she is. Okay. All right, let me share my screen. You all seeing this now? Somebody take the lead.
Yes.
Okay.
Yeah, I can see it.
Very good. All right. So this was Monday's assignment. People asking me, first of all, I explained all of this in my opening remarks video, but anyways, people, oh, I can't see anything. Okay, here's an idea. Just click on it. It says assignments, click on it. To open it up, you click on it. To close it up, you click on it. That's all it is. Or you can use this little triangle. In the video, I talked about the triangle. Just clicking on the assignment opens it up. All right. What's I assigned for tonight? I call it assignments and homework. All right. The assignments are the parts where I'm asking you to watch the videos. All right. So I'm asking you to watch sections 2.2 and 2.3. This one is about 24 minutes. This one here is about only 6 minutes long. All right. Then I have my PowerPoints, my voiceovers where I walk you through it. What I'm going to be doing tonight, I'm going to go back to section 1.1, the very beginning. All right. And walk you through some of the PowerPoints. Now, I haven't got the entire PowerPoint up there because it'll take too darn long, but I've got the key features. Hold on, just let me mute myself for 1 second here. All right, pardon me, that was one of the cats that we have is downstairs. I got the door locked anyways. All right. Then after watching my voiceover homework, all right, please do not ask me, am I collecting or am I grading the homework? I tell you that up front. No, my homework assignments are all multiple choice. How am I going to correct something where I gave you the answer already? It's like I'm correcting my own work. You'd think you would kind of like that I'm not collecting homework. I'm taking you at your word. You're college students. If you haven't figured out that you're going to do homework at this stage of the game, me collecting it is not going to do a bit of good. All right, I have all the PowerPoints. Here again, nothing wrong. I wouldn't bother printing these out and wasting all that paper, but at least download these PowerPoints so you have them available. Now it comes time for the tests, I would have maybe my PowerPoints available, but primarily I would have my solutions, and I'll post those too. I'll post the answers prior to. In fact, I'll maybe do it this weekend. By that, I'll say I'll have a section. It'll say worksheet solutions, and I'll have all the answers circled. All right, I gotta make sure I do that. All right, so after completing the homework above, in other words, the homework here is doing sections 2.1, 2.2, and 2.3. Then I actually go through it. I have a voiceover. What I will do is post the Acrobat, the Adobe PDF, where the answers are there and the solutions are there. Of course, you're not going to hear my voice, but I will post that. I'll make sure I get this done within the next couple of days, and I'll shoot you an email. Moving on, we finished chapter 1, sections 1.1, 1.2. We've done chapter 2, 2.1, 2.2, 2.3, and then we're on to chapter 3. As in any course, the first couple of chapters are really, really basic. In our course here, the first couple of chapters are just definitions and vocabulary. So we're all kind of speaking the same language. And then obviously again, the other course, the material gets a little more strenuous, requires more thought. But the good news is your calculator is going to be a big help to you. All right, moving on. After you've done that, I'm asking you to watch video section 3.1. Then I have a PowerPoint for that video voiceover. There's the actual PowerPoint where you can download it. And we're going to be working a lot with the calculator. And I think I'll have time. I'll figure out as things go on. I'm going to actually pull up my TI-84 calculator. Hopefully, the majority of you took my advice. And if you did rent one from the college, you did request an 84. But here's the other issue. The 83 is fine, but there are some discrepancies. And then there are some 84 calculators that have an older operating system and they behave like an 83. So I addressed that within the course, the differences or the discrepancies if you're using the 84 or the 83 model. I'm hoping that the majority you have the 84. All right. So We've got our meetings on Wednesdays. There's an optional office hours. Use that same URL at 11 o'clock. I'll be on from 11 to 12. You can always email me. No one's making use of the discussion board. It's just another way of getting a hold of me. Probably a better way of getting a hold of me is just, jgomes@massasoit.mass.edu. All right. Hopefully that takes care of that. Let me just open up. Give me a second here. And let me share this first screen, which is the PowerPoint from section 1.1. Here again, it's not the entire PowerPoint because you've already looked through that. I just want to go through some key factors, some key issues. I want to rush through this. All right, there'll be plenty of time, but it's just just getting started. So hopefully everybody can see my PowerPoint here.
Yes.
All
Yeah.
right, just do something here. Let me. I want to stop my video. All right. And that's out of the way. Getting started. All right. I'm actually going to play this video. Hopefully you had a chance to watch it, but I think it's kind of important. It's short. It's only about, I think about 2 or 3 minutes. Hopefully you can all hear this. Are you seeing my video here?
No,
Yeah.
You're not seeing this video?
no.
It's like
No, it
buffering.
hasn't started.
Are you?
It started.
Is becoming increasingly data.
Oh, it's just a black screen for me.
Okay.
Yeah, it's a black
All
screen
right,
for me,
all
but
right,
I
I
can.
got it. I got it. I got it. How about now?
Yes.
Yeah, I can see it now.
Okay. Still seeing it?
No.
No,
Okay.
it just clicked off.
Disappeared.
All right. So obviously I can't play it out of here. All right.
But statistics goes beyond a batting average or shots on goal. In fact, everything is becoming quantitative, with data that is not just in numbers, but numbers that carry information. For example, medical teams design experiments to analyze the
What the video does. Get back to my Zoom here. What that video does is basically just talks about the importance of statistics in everyday life. What is in statistics now, especially, since last March when we were hit with this pandemic, everything has been numbers. So many people in this state are vaccinated, so many people, you hear this all the time, 58% of the entire population has been received one vaccine shot, or unfortunately, X amount of people have died in this state and that. We're surrounded with statistics. And what really drives me up a wall is, they'll say, well, 63% of the American public want the federal government to legalize marijuana. But they never quite tell you how these numbers were derived. They just come up with some statistics. They never say, well, the sample size was, 4,000 people. We surveyed people from 20 to 29. They just throw the number at you, but never tell you how the number was derived. And it just drives me up a wall. And I think why the news media doesn't get into how the statistics were derived. They just don't think people are smart enough to figure it out. So they just throw numbers out there. And what happens is people take these numbers and they regurgitate them, but don't know where the numbers came from. Statistically, how did they derive it? But anyways, just drive me. Hope you have a chance to. The idea of that video is statistics is in every subject matter, every discipline, from business to medicine to politics, you name it. Somehow somebody's using some data. If it's not that, it's, you think about the phone calls that we get, these telemarketers, the amount of information that these people know about us. But anyways, all right, stats, study how to collect, organize, analyze, and interpret numerical information. The question I get a lot from people is, are there going to be definitions on the exam? Here's the key. My homework assignments that I give you mirror what you're going to see on the exam. They're going to be multiple choice. All the questions are multiple choice. There are no fill-ins. All right. Second of all, on my homework assignments, I have a test generating program. All right. What I normally do for the homework examples is I choose maybe the odd ones, 1, 3, and 5. Well, guess what you're going to see on the exam? Probably questions 2, 4, and 6. They're not going to be the same numbers, people, but the method that you solve it will be exactly the same. And another thing I'll tell you is my exams go in the same order as I present the material to you. So on the first exam, you're going to see, problems from section 1 first, followed by section 1, 2, and so forth. All right, stats, how to collect, organize, analyze, and interpret. The first 3 chapters talk about how to collect data and organize it. And then once we move on to chapters 4, 5, 6, and 7, we're going to analyze and interpret. Basic definitions. Individuals are people or objects that we're studying. A variable is some characteristic. I talk about, for instance, if I want to study about people who climb Mount Everest, then the individuals are the people who actually climb Mount Everest, who actually made it to the summit. A variable of these individuals may be their height, their age, their weight, their gender, nationality. Regardless of the variables we use, we will not include measurements or observations from people who have not climbed the mountain. These variables, the height, weight, gender, and so forth, could be quantitative or something called qualitative. The definition is quantitative. A quantity refers to that value is something numerical. It's a number, things that we can add, subtract, and average. Something that's qualitative is basically putting a person or a group into a category, such as male or female, Democrat or Republican, Nigerian, Cape Verdean, all right? Putting them into a category. So we have individuals, we have variables, we have quantitative numbered data that's variables that are numbers, quantitative, and things that are qualitative, all right? Describes the individual or by putting them into some certain category. It's important to know whether your data comes from a population or it comes from a sample. Notice what it says here. In population, the data are from every individual of interest. Now, here's the misnomer here. When people think of the word population, you somehow think of the population of the world or United States or maybe the state of Massachusetts. Population doesn't have to be a huge number. I could be working with our class. We have 27 people in our class right now. That constitutes a population. It's only 27 people, but it's everybody that I'm interested in, all 27 of you. A sample is data from only some of the individuals in our class. For instance, I may be interested in just the people who are sophomores. I'm not concerned with everybody in the class. I'm just want a certain part of the class, let's say the men or the women, people who live in Brockton. That would be sample data. If I'm working with the entire population, all right, I'm working with every individual of interest. If I'm working with a sample, I'm only working with some of these. And usually when we do statistics, we do surveys, we can't survey everyone in the United States. So what we do is we take our sample, all right? It's important to know whether the data are from a population or is it from a population or is it sample data. Population parameter is a numerical measure that describes some aspect of the population. Now notice the key here. Population goes with parameter. If I have a sample statistic, all right, is a numerical measure that determines or describes some aspect of a sample. So sample goes with statistic or statistic goes with a sample. The S's matches up. A parameter is associated with a population. I can see a question, you've already saw it already. I think the question is, We inspected all the meat in a particular meat producing factory. Is this number 44,000? Is it a parameter or is it a sample? So I'm sorry, a statistic. Well, if I'm working with all of the meat, I have the entire population, I've got a parameter. If I'm working with just some of the meat or whatever, I'm working with a sample. Population parameter, sample statistic. We've categorized data as being qualitative or quantitative, but another way to classify data is according to one of four, what they call levels of arithmetic, all right, or levels of measurement. These levels indicate the type of math or arithmetic that's appropriate, such as ordering, taking differences, or taking ratios. Four levels are nominal, ordinal, interval, and ratio. You've seen this already, which I'll go over section 1.1's homework. They give you a question, they ask you, hey, is this at the nominal level, the ordinal, and so forth? All right. Examples, everything falls initially into the nominal level of measurement. It's the lowest level, all right? Examples of nominal variables, someone's blood type, your zip code, your gender, your race, your eye color, your political party. Note, the nominal data examples are nouns. There's no sense that I can order these. I can't order zip codes. I can't put somebody's, if I had all your blood types, I can't say, well, A and is better than B. I mean, it comes after B in the alphabet. I can't order that. I can't order gender, male and female. I can't order race. Nominal level is just a label. Hey, you're a Democrat. You have blue eyes. Your zip code is 02743. Your blood type is A negative. Nominal level. Ordinal level. Well, I can order. Just the word ordinal, the key word there, root word is order. Class rankings. Good, better, and best, a restaurant. I'm going to a good, better, and best, a 1-star, 2-star, 3-star hotel, grades that you receive. Now, the idea is I can order this. I know that better is better than good and best is better than better. I know a 2-star restaurant is better than a 1-star, but here's the key with ordinal data. Differences are meaningless. You know, I go to a 3-star restaurant versus a 1-star. How much better is the 3-star better than a 1-star? The differences are meaningless. Someone gets an A and someone gets a B, but the one person A may have been a 96 and a person that got a B may be an 82, but another pair, the A may have been a 93 and the other person had a 87. The A, B, and C, I really don't know. I know an A is better than a B, but the margin, the difference between the averages, I'm not told, so differences are meaningless. Class ranking. You know, you may find someone with a 3.7 and then somebody with a 3.6 that was second in class, but the third person may be, you know, had a GPA maybe of only 3.0. The differences between the first person and the second may not be the same as the difference in GPA from the second to the third. All right, differences don't make any difference. They're meaningless. Here's a key thing. The next level of measurement is interval. I'm going to tell you this right now. There are only 3 things that fall into the interval level. If you see temperature, when I say temperature, I'm talking Celsius and Fahrenheit. You see an example that has temperatures automatically interval level. They're labels, I can order them, all right? But the key thing with interval level, there is no zero starting point. When it's 0 degrees out in January, it doesn't mean there's no heat. It just means it's down cold. Dates in time. Well, time didn't start with the year 0. Time of day. You look at your watch, you don't see any 0 on your watch. All right. Interval levels. These are the only 3 things that fall into interval level of measurement: temperatures, dates, and times. Now, notice I said Celsius and Fahrenheit. If you're a chem major, you know about Kelvin. All right, degrees Kelvin. Well, degrees Kelvin, 0 means there's no heat. All right, so I'm not talking about Kelvin. Here's another thing. Don't be looking for the abstract answer. All right, I'm not out to trick you. Don't be looking for that one thing that, you know, oh, what about this, Mr. Gomes? This, you know, what about, you know, and the example I use is the person, I asked a question, what's the probability it turns dark tonight? The 3 solutions were 0, 1, and 1/2. Well, it's gonna get dark tonight. It's a sure thing. When something is a sure thing, it's one. This person answered 1/2. I asked the person, why did they answer probability of 1/2? He said, well, what if I live in Alaska or Greenland? So I opened the window. I said, are we in Alaska? You know, don't look for that crazy one. I'm not trying to trick you. It's pretty straightforward. There's always going to be exceptions to the rule, but don't go searching for some crazy exception like, do we live in Greenland or do we live in Alaska? All right, so nominal, ordinal, interval. And the very last one is the ratio level of measurement. All right, examples of ratio scale of measure include somebody's age, their wages, units of production, weight, changes in stock prices, distances. Money is a great illustration. If you have $0, you have no money. If you make $50 an hour, you make 2 times as much as a person who makes $25 an hour. All right, so these are the examples. If it passes the nominal level, the interval level, the ordinal and the interval, it finally ends up into the ratio level of measurement. But there are certain things, you see temperature, you know it's interval, somebody's age, or wages, you know automatically it's the ratio level of measurement. All right, that's pretty much section 1.1. Like I said, I didn't do all of the slides because it would take too long. So I'm trying to highlight the key parts of this. So that being said, I got a chat here. As Miss Fernandez is telling me she was out having a drink somewhere. It's okay, Miss Fernandez, I understand. Where else? Miss Fernandez. Miss Fernandez, where are you? Oh, there you are. Okay. All right. No need to apologize. I get it. Let me ask you a question. You folks looking forward to going back to class in September? Anybody?
Very much so.
Yeah, definitely.
Yeah. They still have courses that are going to be online, but I know I teach at Bridgewater as well, and Bridgewater is enforcing everyone, all the students to be vaccinated. What have you folks heard about Massasoit? Last I heard, they're not forcing students to be vaccinated. Is that true?
They
I
haven't
haven't
told
really-
me, so
I'm sorry?
I haven't heard anything, so I'm not sure.
Yeah. The reason I say that is, you know, what you're hearing now with these variants, sometimes people who have been vaccinated, you're hearing people actually contracting COVID. Now, obviously, the symptoms not going to be as severe. You're not going to die from it, but you can still, you know, give it to somebody else. And I'm very aware of this because my mother-in-law is in a nursing home. And my wife can't go see her as of today because one of the employees tested positive for COVID. And it appears that even in nursing homes, they can't force, in Massachusetts, they can't force employees to get vaccinated. I had my hair cut today, and the young lady that cuts my hair, she still requires a mask in her shop. And I kind of agree with that. It's her shop, she wants to be safe. And she says, hey, listen, you don't like my rules, basically go find somebody else to cut your hair. So there's a lot of stuff out there, but I don't want to get into it because that will take us down a road I really don't want to go into. Whatever your political beliefs are or vaccine beliefs, it's none of my business. I'm here to talk about statistics, but I'm just curious about what's happening with Massasoit. I'm teaching one class. It's in the morning. It's on campus. So in a way, I'm looking forward to getting back. All right. So we went through levels of measurement, some key definitions, individuals and variables, quantitative, qualitative. Now we're ready to do some sampling. You know, we're going to perform statistical analysis, but before we can perform this statistical analysis, we got to collect some data. All right. This section here, section 1.2, kind of zeroes in what's called simple random samples. In this section, we examine several widely used sampling techniques. And here again, when you hear this stuff on the news, you know, 83% of people believe there's UFOs. Well, what 83%? Did you survey your godmother, your cousin? Did you survey 1,000 people? Was it 10,000 people? Where were these people? Were they in the West Coast, East Coast? Were they in Michigan, Massachusetts? They never tell you where the data came from. And not only that, they don't tell you what the sample size. They just throw a number out there and they just take, you know, you got to take them at their word. Not that I don't, but it should be nice to know how they came up with these numbers, but they never do that. One of the most important sampling techniques is called simple random sampling. Here's this crazy definition. I won't ask you to obviously to repeat it back to me, but it says this. A simple random sample of n measurements from a population is a subset of the population selected in such a manner that every sample size n from the population has an equal chance of being selected. What's that mean? All right, it's a definition, but I'm trying to see if I my best to explain it without getting, you know, you start reading that, you go, huh, what? What's he talking about? In a simple random sampling, not only does every sample of a specified size have an equal chance of being selected, but every individual of the population also has an equal chance of being selected. However, the fact that each individual has an equal chance of being selected does not necessarily imply simple random. All right, here's a classic case. Let's say we're in class and it's a big class and it holds, let's say, this is 4 rows and we got 10 students in each row. I toss a coin. If it comes up heads, I choose the 20 students that are sitting in the first 2 rows. If it comes up tails, I choose the 20 students that are in the last 2 rows. Does every student have an equal chance of being selected? Yes, 50-50. Comes up heads, I take the first 2 rows. It comes up tails, I take the back 2 rows. Everybody has a 50-50 chance. All right, same example. All right. Is it possible, here I am over here, is it possible to have students in row 3 included in students that are in row 2? Well, no, because if it's heads, I got 1 in the first and second row. If it's tails, I got the kids in the third and the fourth row. I never can get people in the second along with people in the third in my sample. Already, I don't have a simple random sampling. All right, it's not possible based on this method. Since every sample size of 20 is not possible. I can't get people in the first row and the fourth row together. All right, so it's not simple random because every group of 20 should have the same chance of being selected. All right, same question. He says, describe a process where I could get a simple random sampling with all these 40 students. Here's what I would do. I would assign everybody a number. The first person, number 1, 2, and everybody would count out from starting with 1 to the very last person would say, I'm number 40. I would take, let's say I got ping pong balls and I've got every ping pong ball labeled 1, 2, 3, all the way up to 40. I put all the ping pong balls into a little container. I spin them around and I randomly reach in and I draw a ball out. All right, maybe I draw person number 1 out. Then I draw person 38 out. Then I draw person 22 out. That would be an example of a simple random sample. Everybody has the same probability of being selected, but every group, let's say of 20, has the same chance. Now I can get people in row 1 mixed with people in row 2, with 3 and 4. This is what constitutes simple random. All right, to do sampling and to have your sample have any validity, it's got to be simple random. You just can't pick and choose who you're going to sample and think that you're going to get an accurate result. Simple random sampling. They talk about here, you know, usually a computer, whatever, but I'm saying, you know, number these ping pong balls from 1 to 40 and then randomly select them out and you'd get a simple random sampling. All right. Other sampling techniques. The easiest is what's called convenience sampling. You know, you're interested in how many people believe in UFOs. Well, convenience sampling is you call up 5 of your friends. You ask them, hey, Fred, do you believe in UFOs? Hey, Mary, do you believe? You'll get some responses, but I'm not sure they're going to be so accurate because they're your friends. And usually they're your friends because they believe in the same things you believe in. All right. It's convenient. It's better than no information at all, but convenience sampling does run the risk of being severely biased. For instance, consider a news person who wishes to get opinions of people about a proposed seat tax to be imposed on tickets to all sporting events. The revenues from the seat tax will be used to support local symphonies. Well, this guy stands outside of a symphony. And yet, he surveys people coming up. Well, of course, they're going to be in favor of a seat tax because it's going to help pay for symphonies. All right, convenience sampling. It's very easy, but the outcome, the results of that's going to be severely biased. It's convenience sampling. It's very easy, but it doesn't hold much validity. All right, it's a good advice to be very cautious indeed when the data comes from convenience sampling. Second one is systematic. And the key word, the root word in systematic is system. In this method, it is assumed that all the elements of a population are arranged in some sort of natural sequential order. Then we select a random starting point and select every kth element. Now, what's that mean? Let's say you go to a rock concert. I'm better still, not being a rock. Let's say you go to a Red Sox game and people are lined up in order. All right. And what you would do if you wanted to impose or to illustrate systematic sampling, you go up maybe to the third person in line, you ask them a question that you're interested in. Do you believe in UFOs? You start with that third person, and then maybe now you pick the 5 people after that. You pick the 8th person, and then you pick the 13th person, and then the 18th person, and then the 23rd person. You pick every 5th person after you start at a certain starting point. People are lined up. You're not interviewing everybody. You're starting maybe with the 2nd person in line, then you pick the 6th person, and then the 10th, and then the 14th and the 18th. It's called systematic sampling. It's got a system to it. The advantages of systematic sampling is it's easy to get. However, there are dangers. And in your PowerPoint, it talked about the full PowerPoint, it talked about a fabric factory where they're inspecting every 17th yard of fabric to see if it's, it's good to sell. Well, maybe the looms are making a mistake at every 13th, yard of fabric. So checking every 17th isn't going to obviously show you the defect. So it's easy, but it has its drawbacks. All right, the next 2, stratified, and the last one would be convenience. They're very, very similar, but I'll show you the difference. Although we will assume throughout the text that simple random samplings are used, other methods of sampling are also widely used. Here's what I'm going to say. When you come across these problems, all right, sampling techniques, the answer, you'll have 5 different choices. The answers to these questions will never, 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 never be simple random. Reason I can't ask you that is simple random is included in stratified, and it's also included in the next sampling technique, cluster. So you'll have 5 answers, but never choose simple random. It'll either be your convenience, it'll be your systematic, it'll be stratified, or the last one we'll talk about, cluster. The answer will never be simple random. In stratified sampling, we group classes into populations that share some common characteristic. This common characteristic is called strata. The classic example, you go to college, you've got, or even a high school, you got freshmen, sophomores, juniors, and seniors. Those are my strata. Other strata, let's say in college, would be men and women, in-state or out-of-state students. In the method of stratified sampling, the population, these college students are divided into at least 2 distinct strata, male, female, in-state, out-of-state. And here, freshmen, sophomores, juniors, that would be divided into 4 distinct. Now, once I determine my strata, whether it be freshmen, sophomores, male, females, then I take a simple random sampling of my strata. In my PowerPoint, I actually link to 4 different videos that kind of go into this in depth. All right, stratified sampling. Now, cluster and strata sound a lot alike, but here's the key thing. If you're debating between stratified and cluster sampling, in cluster sampling, we divide, usually it's used in government agencies, and it's used sometimes in private research. We divide a demographic into sections, but the key thing in cluster sampling, every member of the cluster is included. So when you see a problem, when it says I surveyed all of these people, all of these people who live in Bristol County and live in Suffolk County. You see the word all, then you know it's cluster sampling. There are certain key words that kind of give it away because cluster and strata sometimes the definitions kind of they kind of overlap, but the difference with stratified and cluster sampling is in cluster sampling, you're not doing a simple random, you're interviewing or you're interviewing every member. You'll see the word all. In fact, even in the PowerPoint, I think I even underlined the word all. So you know it's cluster versus stratified. Convenience sampling is fairly easy to figure out. And even systematic is easy because it's, you have a starting point, you pick every 5th person or every 10th person and so forth. It's cluster and stratified that gives people problems. So I hope that helps.
Officer, I have a question.
Mhm.
Okay, so my question would be, when you were talking about the stratified and the
Yeah.
cluster, you talked about using the high school situation as an example, like the freshman,
Freshmen,
the
sophomores,
sophomore, and yeah. So can you say that the cluster is the whole of the high school?
the what?
The whole high school would be a cluster, right?
No. Cluster would be, let's say, cluster is usually used in geographic things. For instance, let's say I take a map of the Massachusetts, there's like 13 counties. A cluster would be everybody lives in Bristol County. Another cluster would be everybody lives in Norfolk County. All right. The
Oh, okay.
freshmen, sophomores, juniors, and seniors, those are strata. The population is the entire school, but I'm breaking them up into groups that have something in common. There's something they have in common. All the freshmen are in their first year of high school. All the sophomores are in their sophomores, they're in their second year. So I'm not confusing the two. Strata and cluster. Cluster, difference is in cluster sampling is all right, let's go back to that high school. If I were to say my clusters are freshmen, sophomores, juniors, and seniors, what I would do with cluster sampling is I would pick maybe the freshmen and the sophomores, but I would interview everybody in their freshman class and everybody in the junior class. In stratified sampling, I'm just interviewing some of the people. For instance, let's say there's 150 freshmen and 200 sophomores. Well, since there's more sophomores, in stratified sampling, I'm going to pick by simple random. I'm going to pick more sophomores than I'm going to pick freshmen. In cluster sampling, I'm choosing everybody in that cluster. That's the distinction. Everybody versus just some of them. I'm going to go through this, and there's a couple of examples I'm going to show you. Then hopefully it will be a little clearer for you. The key thing is the word all. If you see all, you know you have cluster versus having a stratified sampling. Let me pull. I hope when I get to this, in fact, I'm going to do it right now. I finished 1-1 and 1-2. Give me a sec here. All right, this was the first homework assignment you had. Now, I purposely didn't circle any answers because I didn't want to stack the deck. A lot of what you're going to see here in statistics, initially, and even towards the end, you got to use some common sense. All right, common sense. Andrew rolled a die 5 times and got a 6 every time. Possible and likely? No, it ain't likely. Impossible? No, it's not impossible. It could happen, but the idea is it's possible, but very unlikely that you take if you don't believe it, take a die and you roll it 6 times and tell me how many times every 1 time you rolled it, you got you rolled it 5 times. Take a die, roll it 5 times and tell me how many times every one of those 5 die times you rolled it, you got a 6. You may have to roll it maybe 50 times before it happened. It's possible, but very unlikely. Kind of common sense. This one here, you probably wouldn't have known. There's something called the birthday paradox. You got 2 people have the same birthday in a school of 150 people, 150 students. Now, when they say in the same birthday, they're not meaning the same year. They're saying the same day, same month and day. If we were in class, I actually performed this little experiment. If I've got 25 people in class, you know, there's a 50-50 chance that two people have the same birthday. Once again, not the same year, but the same month and day. You know, it's 50-50. You got about 60 people in a classroom. Someone has their speaker on, their microphone. Would you please mute yourself? If I've got 50 people in front of me, there's almost a 99% chance that two people have the same. You say, how can that be, Mr. Gomes? 50 people, there are 365 days in a year. It's called a paradox. A paradox is something in math, or paradox is something that doesn't seem to make sense, but it's true. So the answer here is it's possible and very, very likely. If I have 150 students, yeah, I'm gonna get two people with the same birthday, same day, same month, and same day. Lori rolled a dice 3 times.
I don't know what time you think they close, girl.
I wish somebody would mute themselves, please. We don't need to be hearing you. Hello? Hope they fixed that. This disturbs everybody. All right. Hopefully that person muted themselves, or I'll mute them. I don't want to get out of this screen. All right, determine whether you have a stat or a parameter. A stat is associated with a sample. A parameter is associated with the entire population. The very first second word says a sample. Well, the minute I see I've only got a sample, then whatever this is talking about, the average age is 37 years. It's a statistic. Why? Because it's based upon a sample. Sample goes with statistic. Number 5, after inspecting all of these 55,000 kilograms. Well, if I get all of them, I have the entire population. Any number that's associated with this problem is a parameter. Why? Because I have inspecting all of them. I'm working with my entire population. My answer, or it was found that 45,000 kilograms were spoiled. Well, 45,000 is a parameter. Why? It's based upon a population. Here we go with those problems dealing with levels of measurement. Very first thing, I see temperature. The minute I see temperature, I know I'm dealing with the interval level of measurement. Easy beans. Salaries. Salaries are money. Money falls into the racial level of measurement. How do I get there? Well, everything starts out at the nominal level. Mr. Gomes makes $2,000. That's a label. Can I order it? Well, Mr. Smith makes 4,000. Well, yeah, 2,000 is less than 4,000, or 4,000 is more than 2,000. I can order that. Interval level of measurement. Are differences meaningful? Yeah, 4,000 is 2,000 more than 4,000 is twice as much as 2,000. But here's why it goes into the ratio level. If someone makes 4,000, it makes sense to say they make twice as much as somebody who makes 2,000. Getting back to temperatures, people often say this, oh, when it's 40 degrees out, it's twice as hot when it's 20 degrees. No, there is no zero. Zero doesn't mean, when you don't have any zero, ratios don't make any darn sense. Well, number 8 is the same as number 6, and maybe I shouldn't have that. The word is temperature. The minute I have temperature, I know I'm in the interval level of measurement. All right, ages are like salaries. When someone's 30 years old, they're twice as old as someone 15. And when you're 30, you're half as old as someone is 60 years old. Ages. Off of that slide, it's the racial level of measurement. ABC, well, the slide I gave you, all right, this is the ordinal level of measurement. It can't even get to the next level. It can't get to the interval level. A, B, and C, well, some A's may be a 94, other A's may be a 92. I know an A is better than a B, but differences are meaningless. Unless I know the actual grade the person got, I can't take any differences. Grades, all right. 1 star, 2 star, 3 star, good, better, and best. These are all things that fall into the ordinal level of measurement. Some basic calculated things, because you're gonna have to do this, convert 7/11 to a decimal. Well, on your calculator, you divide 11 into 7. And I'm not even sure what the correct answer is, but I would imagine I think it's letter C. You probably can't see this, but let me do this. Let me fire up. Man, I'm not even gonna do it right now. I don't wanna, you can't see my calculator, can you? No, all right. All right, take 7 divided by 11 on your calculator. How do you change from a decimal to a percent? You take the decimal point and you move it 2 places to the right. In fact, off to myself, I'm gonna just figure this out myself to figure out what it is. You can't see my calculator. I'm just taking 7, I'm dividing it by 11. Sure enough, I came up with 0.636. All right, so it's letter C. How did I go from 0.636 to 63.6%? I'm basically multiplied to change a decimal to a percent, you multiply it by 100, which means take the decimal point and move it 2 places to the right. Convert 25% to an equal to a fraction. 25% is 25 over 100. 25 over 100 is 1/4. As a decimal, 1/4 is 0.25. You don't want to make a careless error here and say that 1/4 is 2.5. No, it's 0.25. Convert 0.368 to an equivalent fraction. All right, there's actually a way on the calculator that you can do that. And let me just do this now. 0.368, hold on a minute. This is kind of important because sometimes you're calculating your answer, you come up with a decimal, but the answers on the test are in fractions. So let me do this. Give me a sec here. I want to stop sharing that. I want to share my calculator. All right, he was asking me to take 0.368. Let me show you how to do this. I'm going to enter in 0.368. Now, if I read this, it's 368 thousandths. I really don't want to spend the time to take 368 over 1,000 and try to reduce that down to lowest terms. It'll take me 5-10 minutes. All right. Here's the easy way of doing it. I enter in my decimal. I go to my math key. I press math, and the very first option is fraction. What it's going to do, the calculator is going to do, take that decimal 0.368 and hopefully change it to a fraction. I'm going to press enter and then press enter again. And what does it give me? 46 over 125. An easy way of converting a decimal to a fraction. Once again, you go to your math key, you go to your fraction, and you hit enter, and it does it very nicely for you. All right, so we had 46 over 125. Notice there's 2 answers that are very similar. All right, they have the first part right. But the idea is that 0.368 as a percentage, moving that 0.2 places to the right, is 36.8%. It's not 3.68%. You got to be careful. A lawyer has 40 clients, 10% of whom are businesses. How many clients are businesses? Well, what's 10% of 40? It's 4. It's 1/10. 1/10 of 40 is 4. On a test, you had 130 questions and you got 33 of them, 33% correct. What's the number of correct answers? Well, 33% of 130 is basically 1/3. I don't have to even think about this. 1/3, say, call this 120. 33%, 1/3. 1/3 of 120 is 40. Since this is a little bigger, my answer is going to be a little bigger. It's going to be 43. It's certainly not going to be negative in anything. It's not going to be 83. It's not going to be 60. Here's an example here. I can kind of figure it out in my head. 1/3 of 130 is approximately 43. If you didn't believe that, take your calculator out, multiply 33%, which is 0.33 times 130, and guess what you come up with? 43. This is another crazy one. I mean, such common sense. You got 80 questions on a test and you got 76 of them right. Did you do pretty good? Yeah, getting 76 out of 80, all you got was 4 wrong. What was your grade? Well, you sure didn't get 105. There's no such thing as 105. You didn't get 0.9. You didn't, 0.95 is not even 1%. You didn't get a grade of 5%. You got a grade of 95%. Gee, you answered 76 out of 80. All you got was 4 wrong. You did darn good. So good you got a 95. These other 3 answers make absolutely no sense. Yet people get these easy ones wrong. And I'm trying to say, use some common sense. Well, I never did good in math. Well, keep saying that. You're not going to do well ever. Have some faith in yourself. Common sense. 76 out of 80. You did fantastic. You got a 95. You certainly didn't get a 5. You certainly didn't get 105. This one here is not even 1%. It's 0.95%. All right, getting back to the young lady who was asking me that question. I forget her name. She was debating cluster and stratified sampling. Here it is. You pick 49, 34, and 48 students out of the sophomore, junior, and senior class. They had these enrollments. Well, I'm telling you that the answer is never going to be random. So get that out of the picture. It's not convenience. It's not cluster. It's not systematic. What you've got here is stratified sampling. It's exactly what it is. You break this high school into strata, things that have something in common. Well, all the juniors have something in common. The juniors, all the seniors have something. But notice I didn't pick, once I broke them into strata, I didn't pick all 496 or all 348. I just picked 49, I picked 34 and 48. I just picked some of the strata, stratified sampling. A market researcher selects 500 drivers 30 years and under. All right. 500 drivers under 30 years old and 500 drivers over 30 years old. Here again, these are strata. All right. Strata means they have something, the strata people have something in common. Well, some of them were over 30 and some of them were under 30. It's never going to be random sampling. It sure as heck wasn't systematic. It wasn't cluster because I would have to choose everybody. Nothing convenient about this. I'm working with 1,000 people. It's stratified sampling. The strata are the people that are over 30 years old and the people that are under 30 years old. A tax collector selects every 1,000th income tax. Well, he's got a system to this. He selects every 1,000. You pick the 1,000th person, you pick the 2,000th person. It's like going to the Red Sox game and you start, asking people the 5th person in line, maybe the 8th person, the 11th person. You have a system to what you're doing. You've got systematic sampling. Once again, it'll never, and none of these problems will be random. Now, after I say that, what do I have here? If you looked at, well, no, it's actually number. I'll get to it in a moment.
Excuse me, Professor. I can only say the calculator. I just wanted to be sure if that's just me.
The what? Say it again. Say your question again.
I think she wanted to see your other screen, not your calculator, if I heard her correct.
I'm still sharing my calculator.
Yeah, that's what I see. I don't know, maybe my own screen.
You should be seeing this.
Yeah, so I'm just seeing this right now, but it was just the calculator all the while.
I wish somebody had said something. I wish somebody had said something. I didn't stop sharing. Which, if you're not seeing what I'm talking about, please speak up. I have no problem with that. An education research randomly selects 48 middle schools and interviews all the teachers. Well, the 48 middle schools are your clusters, all right? And you're doing all of them, not just some of them. And I see the word all, that I'm surveying all, I know I got a cluster sampling. Once again, these answers will never, none of the answers will be random. Now, as soon as I say that, this number 21, if you looked at the answers, when I did my voiceover, the answer to this one was random. I'll never give you a question where the answer to it is random. It's either going to be systematic, stratified, cluster, or it'll be convenience. Random will never be a choice. We stop sharing that. Have I got 8 o'clock, 8:02 there? All right, let me close this down. I don't want to save any changes to that. I'm gonna close this up too. All right, you should all be seeing chapter 2, organizing data. Help me out. Yes, no, maybe?
Yeah, I can see it.
Good.
Yeah.
Good. All right, so we've taken the time to collect this data, whether we used convenience sampling or whether we use stratified sampling, systematic or cluster sampling. All right, so we have a bunch of data. We've collected it. We've decided, hey, this is how we're going to collect it. We're going to use one of the 4 methods. Now we got to organize this data so it makes sense. The whole purpose of collecting data is to come up with some valuable information that we can share. Now, whether maybe it's our boss in our company says, hey, go out to the employees and find out how everybody feels about maybe working from home, or what's the percentage of people that want to work maybe a 4-day work week, maybe 10 hours a day versus coming in every day. Whatever it is, you collect the data, figure out how you're going to collect the data. All right, whatever kind of sampling technique you're going to use, but now you got to organize it so it makes some sense. Hopefully you're familiar with the woman Florence Nightingale. All right, we think of Florence Nightingale as being a nurse. In fact, not only was she a nurse, but people don't know that she was a passionate statistician. All right, she was one of the first nurses to use graphic representation of statistics, which charts and diagrams. And she came up with an idea how to improve sanitation. All right, how sanitation could decrease the mortality rate. The idea is at the very end, it says this: when the sanitary reforms recommended by Nightingale were instituted, the mortality rate dropped from 42.7% down to 2.2%. What she came up with is that during this Crimean War, these doctors and these nurses weren't washing their hands. And all it was, some basic recommendations on sanitation, and the mortality rate dropped 40 points. So you think about, Florence Nightingale, you hear the word Florence or the name Florence Nightingale, you immediately think of a nurse. But most people don't even think about the fact that she was a statistician way ahead of her time. Now, organizing this data, well, we've all seen, going back to middle school and grammar school and high school, we've all seen bar graphs, we've seen pie charts. Probably, maybe you haven't seen something like this, but definitely a bar graph. I'm not even going to get into this. It's not even part of the course. It's a frequency graph. Let's assume, all right, you need to know something about people commuting distances. All right, you work for a government agency. You take a sample of 60 people who actually commute to downtown Dallas. All right. One person travels 13 miles, another person 46, and this guy here 9 miles, this lady here 37 miles. All right. But this is great to have all this data, but doesn't make any sense. You need to put it into a form where people could, make some heads or tails out of this. All right. You have the data, but what we want to do is we want to create what's called a frequency table. All right, this is what the frequency table looks like. But I will tell you this, I will never ask you to produce a frequency table. What I will do is give you a frequency table, and I'll ask you information specifically about it. All right, I never ask you to actually do one on your own. Now, we're going to talk about what's considered to be upper and lower class limits. We'll talk about what's class boundaries. Tally. Well, tally is easy enough. What we came up with is that there were 14 people who traveled between 1 and 8 miles to work. There were 21 people who traveled between 9 and 16 miles to work. I'll talk about in a moment what are class midpoints. So to come up with this frequency table, the person says, well, first you have to decide how many classes you want. 5 to 15 are usually used. Well, this is the point. I can't ask you to produce one because somebody may pick 5 classes and somebody else pick 10 classes. So I'm going to give you the frequency table, then I'll ask you questions about it. I don't want you doing it on your own. All right, so it's a good idea to pick between 5 and 15 classes. All right, now let the spread of the data and the purpose of your frequency table be your guides. In the case of the commuting data here, he's going to use 6 classes. All right, next he has to find what's called class width. Class width is the largest data value. In this case here, the furthest commute to downtown Dallas. Subtract the smallest divided by the desired number of classes, which is 6. He says, hey, if your answer is a fraction, I'm sorry, a decimal round to the next lowest number. The person who commuted the furthest was 47 miles. You had one person who only lived 1 mile away. We wanted 6 different classes. 7.7, we increased this to 8. All right, he says, now we determine the data range for each class, the lower class limit and the upper class limit. Since the class, we're going to start out with a lower class limit of 1. He says, since the class width is 8, we're going to add 8 to 1 to find a lower class limit of the second class. We establish all the lower class limits. Then we fill in the upper class limits. All right. So my classes are between 1 and 8 inclusive, between 9 and 16 and 17. Notice here the class width. The class width is the difference between any one lower and the previous lower. 25 subtract 17 is 8. Look at this here. Or it could be the difference between any upper and the previous upper. The difference between 48 and 40. What I'm trying to say is the class width is consistent. In this case, it's 8. Now, how do they come up with the tally system? You know, we're going to find out how many people travel between 1 and 8 miles to work. And what I did here is I took those 60 people, and I just simply put a circle around the numbers that were between 1 and 8 inclusive. I think I came up with what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There's 14 of them. All right, so there's my frequency. There's my tally, 14. There's my frequency. And then I would do the same thing for people who travel between 9 and 16 miles, 7. You get the idea. All right. One thing we use when we have a frequency table like this, sometimes we need to know the midpoint, the halfway point. And how you find that, you simply take the lower class limit, you add the upper class limit, you divide by 2, the halfway point. It's like finding the average, For instance, the midpoint for the first class. Well, if I add 1 plus 8, I get 9. Half of 9 is 4.5. Now, I could do the same thing all the way down. I could say 9 and 16 is 25. Half of 25 is 12.5. I could say 25 plus 32 is 57. I don't have to do that. Once I find the first midpoint, I took the lower class limit, I added the upper class limit, I get 9. Half of 9 is 4.5. Now I knew that the class width was 8. Here's a mistake people make. They think of width as being this dimension here. They'll take 8 and they'll subtract 1. They'll tell me the class width is 7. No, the class width is the difference between any lower and the previous lower. The difference between 17 and 9 is 8. The difference between 33 and 25 is 8. The difference between 48 and 40 is 8. Once I know this first class midpoint, all I got to do is add 8 to it. 12.5, add 8 again, 20.5, add 8 again, 28.5, add 8 again. It's real easy. You don't have to keep adding and dividing by 2. Once you know the first one, you keep adding the class width. It's consistent. These class boundaries, we'll talk about that in a minute when we talk about what's called histograms. A class boundary is I'm simply taking the lower class limit, in this case 1, subtracting 5/10. 1 subtract 5/10 is 5/10. I take the upper one and I add 5/10. I subtract from the lower and I add to the higher. All right. 9 subtract 5/10 is 8.5. You take 16, you add 5/10 is 16.5. Well, the reason behind this is histogram is nothing more than a bar graph, but there's what we do by using class boundaries is we get rid of that space between the bars. So the bars snug up one against the other. You subtract 5/10 from the lower, you add 5/10 to the upper. What could be easier? All right, relative frequency. Many times in these problems, they leave a little piece out. A relative frequency is a decimal, which we turn into a percentage. What percentage or what frequency of people, what relative frequency of people were in this first class? Well, he takes 14 and he divides by 60. You're saying to yourself, well, where does 60 come from? The 60 is the total. All right, what you're doing is you're creating a ratio. A ratio can be changed into a decimal and can be changed into a percentage, but you have to know the total. He doesn't tell you the total, but you had to be bright enough here to say, wait a minute, I'm going to take 14 and divide by the total. If he doesn't tell me the total, hey, I take my calculator, I add 14 with 21 with 11 with 6 and 4 and 4, I come up with 60. 14 over 60, my calculator will give me 0.23, which is 23%. 21 over 60, 0.35, 35%. 6 over 60. The idea is, folks, sometimes he leaves a little piece out, but you have enough common sense to say, hey, a relative frequency, I need to know the total. It's the frequency divided by the total. All right, here it is over here. Notice the sample size is 60. He didn't tell me that. I had to figure that out. I'll add those numbers up myself. And the symbol here, we know what the symbol means. It means approximately. 14 over 60 is approximately 0.23. So there it is again, relative frequency. Sometimes we use raw count, sometimes we use percentages. All right, these histograms. We've all seen bar graphs. Here's an example of a histogram. Notice there's no space between the bars. How I achieve that, or how they achieved it, is by using class boundaries. Subtracting 5/10 from the lower, adding 5/10 to the upper. It snugs these bars right against each other. There's no space. Class boundaries. Subtract from the lower, add to the higher. Sometimes we have a histogram, and my vertical column here is raw count. Sometimes they are percentages or decimals. Notice the shape of the graph is the same. It's just that we're using a different, on horizontal axis, we're using a different scale. All right, this is raw count, and this here is percentages, but the graph, they look identical because they are identical. It's just they were using a different scale on the horizontal. He says, notice the basic shapes are exactly the same. All right, some problems here. I'm looking for the midpoints and the class boundaries. Here's what I said. I will never have you produce one of these. I will give it to you. Like I'm giving you number 5 here, and I'm giving you number 6. And then what I'll do is I'll ask you specific questions about these frequency distributions that I'm giving you. All right, so the midpoints. Well, the midpoint is for the first class. I take the lower and the upper, I add them together and divide by 2. Now, I realize here that my class width is 4. 14 subtract 10 is 4. 18 subtract 14. The difference between these lowers and these uppers is 4. So the minute I know that's 11.5, for the next one, instead of me adding the 14 and the 17 divide by 2, take the first answer, add 4 to it, 15.5. Then add 4 again, and then add 4 again, and then add 4 again. It makes life real easy. The class boundaries, you subtract 5/10 because the distance between one bar and the other bar is usually 1. So to snug those things up, to make a histogram, you subtract half of 1, 5/10 from the lower, giving you 9.5, and you add 5/10 to the upper one. Now the same thing is, subtracting 5/10 from the lower gives me 13.5, adding 5/10 to the upper. But the idea is I could have taken this, added 4, taken that and added 4, do the same thing. 4 more than this is 17.5. I mean, how hard is it to take? Here's a question I may ask you for the class between 18 and 21. What's the midpoint? You would answer 19.5. What's the class boundaries? Well, taking 5/10 away from 18 gives me 17.5, adding 5/10, 21.5. And then I just finish it along. Same thing here. The midpoints for the first one, I'll take the lower, I'll add the upper, divide by 2. My class width here is also 4. So I had 4 more, and then 4 more, and 4 more. It's the same thing I would have gotten if I had taken 14 and added 17, 31. Half of 31 is 15.5. Class boundaries, I'm going to take the lower, subtract 5/10, take the upper, and add 5/10. Subtract from the lower, add to the upper. 1.5 to 5.5, 5.5 to 9.5, and so forth. Pretty straightforward. I don't get much in, there's no questions on the exam dealing with distributions, but I will talk about it. you know, sometimes you have what's called a mound shape, and we'll talk a lot about this in chapter 6. All right, we call this a normal curve. Sometimes you have a uniform or what's called a rectangular histogram. Data could be skewed to the left or data could be skewed to the right. And here you've got what's called bimodal. Here's data that's skewed wherever the tail goes. This is what's called skewed to the right. And this guy here is skewed to the left. I just mentioned that because you may be in some discussion and somebody asks you, well, is the data uniform or is it skewed? But there are no questions on the exam. Cumulative frequency. The cumulative frequency for a class is the sum of the frequencies for that class and all the previous classes. All right. And we also talk about what's called an ogive. I thought I had a couple of questions on cumulative, but maybe they come after. An ogive, well, it's an ogive is used for cumulative frequency. Hopefully I got some questions that deal with that. But anyways, the last thing here is what's called a dot plot. All right, a dot plot. And I mean, this goes back to like, I don't know, 3rd grade. Here's your raw data. Which one of these represents the data shown? Well, I got 1 0. That's all I've got. This guy has 3 dots over 0. There's not 3 zeros. This guy has 2 dots over 0. There's only 1 0. And there it is. Letter C is the only one that has 1 dot over the 0. This guy here has 3 dots. Once I figure out that this is correct, I know this is my right answer and I'm moving on. All right, it's called a dot plot. It's very, I mean, it's almost ridiculously easy. Dot plot. All right, getting back to those cumulative frequencies, we're talking about Aspen, Colorado, and the daily temperature is over 40 degrees. The ice tends to melt, and then it freezes again. The result is the snow crust that is icy can also cause avalanches. Okay. How many days was the temperature between 10.5 and 20.5? 23. Now, cumulatively, how many days was the temperature, the lower between 20 and 30? There were 43. So cumulatively, I'm taking the 23 and I'm adding the next amount, 43, coming up with 66. There were 51 days at the temperature range between 30.5 and 40.5. Cumulatively, I'm taking the 66 and I'm adding the 51. There were 117 days that the temperature was below 40.5. Taking that 117, adding the 27, there were 144 days that the temperature was below 50.5. And then finally taking that 144 and adding 7, I get a cumulative frequency of 151. So it's the value for that one plus everything else. So here's an example. Here's the key to this. Whenever you have a cumulative frequency, it's always going to start out with the words less than. A starts out with less than, B starts out with less than, and D starts out. If it doesn't start out with the words less than, it can't be the answer. So already I'm down to 3 choices. Here's the next thing I'll see. The very first frequency will match the frequency you see here. Well, I don't see 36 here. I don't see 19 here. I see 36. Can't be that one. This one here has got a decimal. Don't want that. This matches up here, 19 with 19. You say, well, where did they come up with the 36, Mr. Gomes? Cumulatively, they took the 19, they added the 17 to come up with 36. How did he get to 51? He took the 36 and he added 15 more. He came up with 50. I'm sorry, he came up with 36 and 15, 51. How did he come up with the 71? He took the 51, he added the next one, 20. The idea is, folks, there's only going to be one that's going to be right. And the key thing is it always starts out with the word less than. And the very first number you're going to see here is going to match up with the very first number there. The minute I saw that, I knew this was the correct one. All right, I didn't have to do anything else. I mean, this is ridiculous. This was decimals. And this one here, I don't know where he's getting these numbers from. All right, that's the idea. This one here wasn't even right from the beginning because it always has to start out with the words less than. Yeah, I made a mess out. That's gonna be there for a while, isn't it? All right, lower class limits. Let me just do this. Let me just do this for a second here. I don't want those lines to show. So I'm gonna do this. Give me a second. And I'm gonna go back and share this again. All right. I want to go back to where I left off right here. He's asking me for the lower class limits. Lower class limits are there, 60, 70, 80, and so forth. Next thing he says, what are the upper class limits? Well, there they are, 69, 79, fairly straightforward. Then he asked me for the class boundaries. Remember, I'm subtracting 5/10 from the lower, adding 5/10 to the upper. All right, 59.5 to 69.5, 69.5 to 79.5, 79.5 to 89.5. Subtract 5/10 from the lower. The midpoints, I'm going to take my lower one, add my upper one, and divide by 2. All right, adding these two numbers, I get 129. Half of 129 is 64.5. I don't have to keep adding the lower and the upper and dividing by 2 because I realize here that my class width is 10. Difference between 60 and 70 is 10. 80 and 70, difference is 10. 90 and 80. So once I got this first answer, this first midpoint, all I could do now is keep adding 10 all the way down to the very end. I don't have to take the time to add the lower and the upper. Just add the class width and I've got my answer. And what is he asking me? The class width, well, I just explained that is 10. Here's a, there's going to be some problems that are going to be very difficult, or I shouldn't say very difficult. They're going to require more thought and more steps. But the easy ones, it's like saying, it's like in sports, you hear teams say, beat the teams you're supposed to beat. The first place team is supposed to beat the last place team. There are some questions on the exam you're supposed to get right. When he asked me, I asked you for class width, please don't tell me the width here, because people think width of being this horizontal dimension. Oh, 69 minus 60, the width is 9. No, the width is the difference between any lower and the next lower, or any higher and the next higher one. All right, it's 10. Believe me, the most common wrong answer, 9, which is definitely wrong, will be on the exam as one of the answers, and chances are it's letter A. All right, get the ones right you're supposed. Don't throw points away. Class width. Don't say 9, it's 10. It's the difference between any one lower and the next lower one, or any one higher and the next higher. And this here is a bunch of nothing, so. In fact, this is what this is here is actually what the entire PowerPoint, not just half of it. All right. Someone's picking up their mom. All right, I've got a half an hour here. Let me do this. Our next section, I'm gonna share my screen here. I'm gonna close all this up. All right, so this is tonight's homework. The very last, you're actually going into, I'm asking you to watch chapter 3, section 1, and then do the PowerPoint. We're going to make extensive use of what's called lists. All right, and there's some basic things I do want to show you in the time remaining that deal with the calculator and lists. And here again, I'm hoping everybody, there's a lot, I mentioned that I'm hoping everybody has an 84 calculator, but in truth be known, there are a lot of similarities with the 84 and the 83. There are certain things that are different, and we'll address those. But anyways, rather than me showing you the video, you can watch this video on your own. As a matter of fact, next Monday's homework, I think I have the same video posted, because we start to make extensive use of the calculator. If you haven't picked an 83 or 84 up yet, I don't know what you're waiting for. There's no way you're going to get by this course. I mean, I don't want you to go out and buy one, but they're available. And I kind of walk you through how you make an appointment to pick one up. In fact, if I'm not mistaken, I think the people in the library are back on campus, so I'm not sure how that works out, but please pick yourself up a calculator. All right, what I want to do now is to stop sharing that and to share my calculator and just to show you a couple of things that I deem super important. Basic stuff. Basic stuff. You should all be seeing my calculator. Is that correct?
Yes.
Okay. All right, first thing is I'm going to turn it on. And, when you turn your calculator on, there may be stuff that's there from the previous time you had it on. So what I'm going to do is press my clear button over here. And that gets rid of everything. Now, one of the basic things, really basic, is a lot of your answers on the exam will be decimals. For instance, I take 8 and I divide it by 9 and I press enter. Well, look what I got here. I got a decimal that has 1, 2, 3, 4, 5, 6, 7, 8, 9, what, 2, 4, 6, 8. I got 10 decimal places. Why do I need to have 10 decimal places? Reason being, any answer that you're going to have on your exam at most will have 4 decimal places. And the majority of them have only 3 decimal places. So I don't want to have to be rounding off by myself. I want the calculator to do the majority of the work. So what I want to tell you to do is set your calculator to either 3 or 4 decimal places. Well, how do you do that, Mr. Gomes? Well, easy enough. You click on mode. All right. It's normal mode. It's not a scientific one. I'm not using engineering. I'm on normal mode. The second option here is float. Float tells me how many decimal places I want my calculator to represent the decimal. I'm going to arrow over and I'm going to set this bad boy to 4 decimal places. All right. I'm going to press enter. Then I'm going to quit out of this. How do I quit? All of these keys on the calculator have a minimum of 2, mostly a lot of them have 3 different functions. All right. The second function of the mode key is quit. But notice quit is in blue. To initiate the quit that's in blue, I have to press the second function, which suspiciously is in blue. I press second function, press the mode key, and then it quits out of it. I'm going to press enter again. Oh, look at that. It took 8/9 and it put it in 4 decimal places. Well, let's say I wanted only 3 decimal places. I'd go back to mode. I come to float. I would arrow over to 3. I would press enter. I would press second function. I would quit out of this. Hey, press enter again. Oh, lo and behold, I got 3 decimal places. What I'm telling you, ladies and gentlemen, don't have it set to 9 places. If you go to mode and you don't see this little cursor over a number, it has no number set. You're going to have 9 places. Set your calculator to 3 or 4 places. You don't want to have to be rounding off on your own. You don't need 9 places. 3 or 4 is the max you're going to need. Do not set it at 0 places. Don't set it at 1 or 2. What I'm telling you, 3 to 4 places. Let me clear this all off. All right, we get involved in what's called lists. By putting numbers in the list, the calculator will do all sorts of nice things for me. It'll find the average, the median. It'll find the median. It'll find the mean, which is the average. It'll find the median. It'll tell me the lowest number in my data set, the highest number. And as we move on, it'll do such great things as finding the standard deviation. It'll find what's called quartile 1 and quartile 2. These are all terms that you don't know unless you have statistics in high school, but these are all things that the calculator will do if you put some values into a list. All right, how do I get to list? I press stat. Now, which is interesting is because the second function of the stat key is called list, but I don't do that. I just press stat. All right, and the very first option here, now I can arrow over to edit, calculate and test and all things like that, but I want to be right here. I can sort my lists, ascending and descending. I can clear my list. I can set up my editor, all kind of neat things. But I'm going to go to this very first option. All right, edit number 1. All right, I have nothing in a list right now. I want to put some numbers in the list. I want to put 78, enter. I want to put 56, enter. I want to put 89. Now, as opposed to hitting enter, I can just hit the down arrow. That'll do a thing. A lot of times there'll be 2 or more keys that do exactly the same. I want to put 41, enter. I want to put in 114 or 100 and, well, we click. All right, what if I want to put 114, but yet I get it wrong? Well, let me just hit clear. Clear will get rid of that number for me. 114, enter. We put one more value in 96, enter. All right. Now I want the calculator to perform some operations. Notice, doing my videos, doing my voiceovers, I tell you this, use list 1 and list 2. If, for instance, you go to your calculator and these lists are all populated, in fact, let me do this. Let me put some random numbers in here, list 2. Let's say I go back to my calculator and I see all these crazy numbers, but I want to put my values in list 2. I could do this. I could go to the very top here and individually press delete. That would delete these numbers for me one at a time. But here's a fast way of doing it. If I arrow above that horizontal line and press clear, guess what happens? It gets rid of all those numbers for me. All right, so you can delete them individually by pressing delete, or you can go here and press clear. If you were to mistakenly press delete now, guess what you did? You got rid of list 1. There's no more list 1 here. How do you fix that if you happen to make that mistake? You go back to stat and you come down to setup editor and hit enter again. Now, if I go back to stat, I go to edit, guess what? My list 1 is back. So make sure if you're going to clear the entire list out, all the values in one shot, don't press delete, hit the clear key. Now, we're going to be doing a lot of things with this. I'm going to just take a moment to show you a couple of things we're going to do. I'm going to go back to stat. I'm going to go over to calculate. Now, there's a lot of different things under calculate. All right. A lot of different things under it. We're never going to use any of this stuff right now. All right. In fact, I'm not sure. It had to be a super advanced course. What we're going to do is we get back to it. The only option you're going to use under calculate is this very first one. It's called one variable stat. I'm going to press enter. It says, okay, you want me to perform some operations. Where is your list? My numbers are in list 1. Well, maybe you didn't put your stuff in list 1. You put it in list 2. How do I tell my calculator that my numbers that I want to be worked on are in list 2? Here's what I do. I go to second function. I press the 2 key because the second function of the 2 key is list 2. Maybe I want list 3. Second function, I hit the 3 key. Well, first I should clear that off. Second function, hit the 3 key. But here's what I'm telling you, ladies and gentlemen. Keep your numbers in list 1. That way there you always know where they are. There'll be times when we'll have frequency distributions and you'll have to use 2 lists. I would recommend putting your values in list 1 and putting your frequency in list 2. You start putting list numbers in list 5 and list 3 and list 6, and then you never remember where the heck the numbers are. You're going to get some wrong answers. So, keep your values in list 1 or list 2. Sometimes you'll need both. All right, so I want to go back to list 1. It's the second function of the 1 key. I only had 1 list. There is no frequency. Those numbers were just used 1 time. So there is no frequency. I'm going to come down to calculate. I'm going to hit enter. What does it do for me? It gives me what's called X bar. X bar is the mean. It took those numbers and it found the average. It took all the values and it summed them for me. I don't need to know that. It took all the values and it squared them. But I will have to know something here. It's called S of X. That's called the standard deviation. That's going to be very important in the next couple next couple of sections, standard deviation. It told me how many numbers I had. I had 6 of them. It told me my smallest value was 41. We don't know what this means yet, but it's going to be important. It tells me what quartile 1 is. It tells me my median, my middle number. Very important. All right. It tells me what quartile 3 is, and it told me my maximum number. The calculator is indispensable. It does all these wonderful things for you. In the upcoming videos, in fact, Monday's assignment, I have about 3 or 4 videos that walk you through this sort of thing, how you put numbers in a list and how you find the mean, the median, quartile 1, all that good stuff. What I'm trying to say is the calculator does it all for you. You don't really have to do all that much work, but you got to become familiar with a calculator. A lot of times people say, oh, I had a problem. I didn't know what to do. And I say, you know what YouTube is? Yeah. How many videos do you think there are on YouTube that talk about the 83 and the 84 calculator? There are hundreds of them. But I'm trying to tell you, folks, you're not kids. You're not grammar school kids. Some of you in your 40s and maybe even older. All right. You got to be a little proactive. It's Sunday night and I'm not online because I'm not online. I'm online a lot, and people that email me know I get back to them in a timely fashion. It's Saturday night at 9:30. Guess what? I'm not going to be on campus. You need to know something to do with a calculator. Go on YouTube, type it in. It'll tell you what's going on. It won't be the first video you come across, but it'll be there. You gotta be willing to help yourself out a little bit here. All right. I'll answer the questions, but darn it, at your age, I mean, no one's spoon feeding here. I mean, you gotta be proactive and do your due diligence. Log on, watch the videos. Well, I didn't understand. Well, watch the video again. I mean, you're college students. How many are sophomores here? Tell me if you're a sophomore by doing what? Reaction. Maybe doing this, putting your hand up like that. Sophomores? Tiffany. All right, Amber's a sophomore. So you've been around a little bit, huh? Yeah, a lot of sophomores. You folks get it, right? This is not a giveaway program. I mean, I'll do my best. I produce all these videos for you. I'll ask questions. I'm going to be online Friday from 11 to 12. I'll do these 2-hour sessions. I'm into it now about an hour and 40 minutes. I'm going to be wrapping it up anyways. Reason I'm going to wrap it up, I just don't want to get ahead of myself. All right, because anything else I do now, I'm asking you to do tonight. Wednesday, you got tonight, you got Wednesday night, Thursday night, Friday night, Saturday night, Sunday night. The next homework you get is not until Monday. So you got like 4 or 5 days to knock this out. And what I'll do next Wednesday is I'll pick it up with, PowerPoint 2.2. I'll go through here again some of the homework assignments. In fact, even Friday, if you log on Friday, have some questions for me. Say, Mr. Gomes, I'm doing section 2.2 homework number 10, but have it ready. Don't be like shuffling around and wasting everybody's time because there's other people that have things to do. So I'm trying to say, be a student, be a college student, be proactive and be ready for me. Time is precious. We don't want to be wasting time. I don't want to sound harsh, but you're college students. A lot of you people are in your 20s and 30s. You've been around the horn a little bit. Do you agree? Somebody?
Yes.
Yes. All right. Brianna gets it. All right. I'm here to help you. But Donna, you got to be doing something on your own a little bit. And like I say, it's troubling when I see some people only have logged on for 5 minutes, and yet I see a lot of you people. I'll tell you something. I'll be very blunt with you. People who take summer courses in 5 weeks, statistically, they do better than the people who take 15 weeks to do it. My summer 1 class, the grades were fantastic. In fact, I had 2 summer classes, 2 session 1s. The grades were great. All right. People that take a summer course know the workload, and they take advantage of the fact that they can knock out a 15-week course in 5 weeks. Come on. Is that the reason you took a summer course, right? Hello?
Yes, sir.
Get rid of it. And Jack, you get done in 5 weeks, right? How many are taking more than 1 summer course? Anybody?
Yes, I have.
How many?
I took in 6 with this one.
Not the semester though, just what, two, how many this semester?
Well, last month I took psych. I took a couple classes last semester, and I'm just taking this one for this month.
Acosta, not Cape Verdean, are you?
No, I'm Dominican.
No, you should have wrong answer. You should have told me you were Cape Verdean. Never mind. I want to ask you again, Cape Verdean?
No, I'm not.
Will someone tell her that she's supposed to answer yes? Miss Ward, will you tell her? No, if you had said Cape Verdean, I would have added 5 points to your average. Are you Cape Verdean?
Yes, I am.
Finally, she gets it. Thank God. Miss Fernandez, Creole? Miss Fernandez? You know, I get the feeling is you go onto Zoom and then you walk off and do something else. Amber, Cape Verdean?
No, definitely not. White and white, Irish and Portuguese.
All right. Well, Portuguese actually colonized. If you go to school in Cape Verde, you speak Portuguese. That was before Portugal owned Cape Verde back in the day, up until 1969. So the official language of Cape Verdean people is Portuguese, but there is a spoken language called Creole, and different islands speak a different dialect. But anyways, I'm Griffin. What's up, brother? How you doing, man? How you
I'm
been?
good. How you doing?
Long time no see. How you been?
I've been doing good. How you doing?
You working this summer?
I work 2 jobs.
What do you do?
I'm a assistant dog groomer, and then I do customer service at my other job.
Making that money.
Yeah, I am.
You married?
No,
Got a girlfriend?
no.
Okay. Gotta make that money for the girlfriend.
Yeah.
Charlotte, what are you laughing at? Charlotte, what are you laughing at?
Nothing. I'm just
You
laughing.
think I'm a joke, Charlotte?
I just laughing.
Katrina, I'll see you Friday, right? Did I answer your question about seeing stuff? How's your mother doing? Hi, Katrina. Katrina, unmute yourself, please. Unmute yourself.
My mom's
mom?
good.
How's
Thanks
mom?
for asking.
How's
My
mom
mom's
doing?
good. Thanks for asking.
Yeah, my mom passed away. I tell you that when we talked.
No, I didn't.
Yeah, she
I'm sorry to
died,
hear that.
She died a month ago yesterday.
I'm sorry. I just buried my mom's sister 2 weeks ago.
Yeah, so you know what we're going through. And my mother-in-law is in a nursing home now. And I was telling the
Sorry to hear that.
well, actually, it's a good thing because we just couldn't care for her here, you know, and she's in a very nice place. It's unfortunate that someone contracted COVID and my wife can't go see her, but
Wow.
it's a close place. And it comes time where, you know, you just can't take care of them and they need the quality of care, you know, and her Alzheimer's was really getting bad. So
Right.
anyways. All right, nobody else wants to talk to me. Brianna just looking at me with something in her hand. Was it a cigarette, Brianna? Oh, it's a magic marker.
Just a pen,
I
no
often
cigarette. or
wonder if I
anything.
ever see somebody smoking online. In fact, I was like, you caught me, I was actually smoking. I have bad habit of smoking. I'm just wondering if I ever see somebody that's online and they're smoking a joint or something. That would ever happen. They forget they're online and they're sitting there getting high. Griffin, you wouldn't do that, would you? Come on, Griff. It's legal.
I don't know what you're talking about.
I have no idea. Okay. All right. All right. Raise your hand if raise your hand if you think Griffin's telling us the truth. I don't
Oh,
know.
nobody.
There's my reaction, Griffin. Amber still thinks this is too funny. Hey, I let you guys go. We've been on an hour 45. You get the idea. Put your time in, watch the videos, do the homework assignments. I'll be online Friday for an office hour, but feel free to email me. What I do a lot of times with people, if you got a question and I think it's too long for me to articulate it in an email, what I'll actually do for you is I'll create a little YouTube video especially for you. Teddy, I'll do that for you, buddy. Teddy,
Sounds great.
where you
Can't wait
at,
to
Teddy?
see
What
it.
town? What town you live in?
Milton.
Okay, you working this summer?
Yeah, yeah, I'm plumbing, doing some HVAC too.
Oh my gosh, try find a plumber these days, huh? You guys are busy as heck, I imagine, huh?
Yeah, oh yeah, yeah. We got a couple jobs going on right now.
So wait a minute, what's your major?
I'm construction management at Wentworth. I'm doing this to supplement my GPA,
Tell
stuff
ya,
like that.
You can find a heart surgeon before you can find a plumber or electrician these days. Good idea. If I had to do it all over again, I would have gone into plumbing, electrical, and had my own company by now. You know, people always need to flush their toilets and they always need lights in their house. You follow me? But you know that. There's nothing wrong with
Practically
having
recession proof.
exactly. Nothing wrong with having a trade, buddy. And what's your major again?
I study construction management.
Construction management. You weren't involved in that collapse of that thing down in Florida, were you?
No, nowhere near it.
You wouldn't tell me if you were anyways, right?
No, I'm only in Quincy. I don't go too far.
You don't go to Florida and construct things that fall down. Yeah. All right. Enough of me talking stupid. Liam didn't want to talk to me. Owen, I don't want. Everyone didn't want. Andrew didn't want to show himself. Tiffany, I don't know what Tiffany's doing. Jack did. That's it. What I'm gonna do is I recorded this. I'm gonna stop recording. I should stop recording at any second now, and I'll actually post this. I'll post this